gas formation volume factor. Okay, so far so good. We can close. Done. Click done. We will check the tank one. All right, now the bubble point is correct already. 2725.3. Okay, tank two. All right, so far so good. So usually as an engineer, you will have this same problem in your daily job, doing MBAL simulation or other analysis. Calculate PB. All right. So now we can go back to calculate and run allocation. Calculate. All right. You can see we have the time, we have the reservoir average reservoir pressure, cumulative oil produced, cumulative gas produced, cumulative water produced, and the calculated oil rate, gas rate, water rate. We can create the plot. Tank one, let's see the tank pressure profile. Okay. Tank two. All right. Tank three. Interesting. All right. So the tank one will have the pressure decline faster compared to tank two, and then tank three. Tank three will show the slowest reservoir pressure decline. You can see because the size of the oil price, the size of the reservoir, or you can see from the initial oil in place, all right? Oil initially in place. Tank one will have the smallest OIP, oil initially in place. That's why we can say it will be smaller in size. And of course, the reservoir pressure will decline faster compared to the third tank or second tank. Okay, remove all. Cumulative oil production, tank one, tank two, tank one. All right, remove all. Tank one, oil rate, tank two, oil rate, tank three, oil rate. Yeah, of course, the oil rate in tank one will decline faster again compared to tank two and tank three. All right, because of the same reason, because tank one is the smallest and then followed by the second tank and the third tank. Okay. Tank one, gas rate, tank two, gas rate, tank three, gas rate. Okay. Because the gas rate will be calculated from the GOR. All right. We have numbers from oil rate, we have values from oil rate, and we also have GOR, right? Tank one, water cut from 0 to 75, all right, in about 11 years. Tank two, water cut. The water cut will rise slower compared to the tank one. Tank three, all right, the water cut increase show the lowest rate compared to tank one and tank two. Again, you can do the plotting, the same plotting technique for other parameters. Okay, so far so good. So we can say that our production allocation is successful. Okay,